Welcome back to Fullerton College Prepress, print 75 and 77. This is your professor, Ben Hewitt. Today's video, we're going to explore task 1.2 of the PIA Prepress Trainees Workbook. Now that I got the boring part out of the way, let's get to the boring part, because we're talking about an introduction to prepress hardware, and some of this stuff is going to seem a bit remedial, but hang with me. There might be some things that are fun or new here for you. Let's take a look. They're going to want us to look at the different types of things that get used in prepress, the physical objects, the actual components, the different devices that are used in the general workflow, which is to say, how do we do what we do as prepress and what tools do we need? Desktop publishing is the phrase from when I was a kid, and as we looked at two times ago with the talking about introduction to page layout software, you guys hopefully watched some of the videos I showed you of paste up, also known as stripping, where the paste up artists, the prepress people, would take photographs, Xerox copies of things, and printouts of just text off of rudimentary laser printers, and you'd cut them and glue them together using X-Acto knives, rubber cement, and rulers to photograph and make your plates for your full production print run. Desktop publishing allowed you to suddenly do that on a computer, which I can also tell you from growing up and not quite having a computer from birth, but having one introduced to my home a little bit later, because they weren't really in everybody's house when I was very young. Also, my family was not that wealthy. We just emphasized getting a computer over other things. We drove crummy cars and didn't have a lot of entertainment options that most people did have. Anyways, you don't need to know that. The point is, when I was really young and I was learning to write in school, if I had to do, when I got to the upper elementary and into junior high, and you had to write things down, you had to do it with a pen and a paper. I know it sounds silly to say this, but bear with me, because some of you have never experienced the pain that I experienced as a kid. When you had to start writing essays, we're not even going to full papers yet, or longer term papers and reports, but just an essay that's about a one-page write-up in 4th or 5th grade. So our teacher would teach us the proper writing and revision process, which, let me tell you, may seem excruciating to you now, but was pure torment to a 10-year-old back in the 80s, because, also technically 90s, I wasn't 10 until it was the 90s. But anyways, you had to write down your whole essay, and then you would get your revisions from your teacher, and when you got a little bit older, also your classmates, when you started doing the part where you look at your friend's paper and let them know how to fix it. So the revision process meant you wrote the whole thing, you got your teacher's notes saying this doesn't make sense, revise this, fix your spelling, and then in order to make those changes, you would grab a new sheet of paper and sharpen your pencil and write the whole page again. Let me tell you that if you ever want to really punish me, the worst punishment you can give you, this person, your instructor, this Ben here talking to you, the worst thing you could possibly do to me is make me do the same boring thing over and over again. I go insane pretty quickly from repetition. I like to have new and interesting challenges and different problems and constantly be solving something else, but rewriting the same paper by hand on paper stinks. And then it was your middle draft, and you still have to do it one more time in pen, in better handwriting, slower. So you write the same paper 3 or 4 times, and I literally mean write with an instrument, like a pen or a pencil. And that was excruciating. When I got old enough and we had a computer, and also when it started to be allowed in school to do your work on a computer, because it wasn't strictly allowed in some of my earlier classes, then I could type a paper. And when I got revisions from my teacher, I could go and fix the spellings in the document. And if I wanted to change a sentence, I could delete that sentence and make a change to that sentence. Imagine the same level of relief of being able to do that over having to handwrite it to when you could use desktop publishing and you could do designs on the computer, and then you could come back and make alterations to it instead of having to start over. Oh my gosh, it is life-saving. So sorry to go on a bit of a diatribe there, but I want you to understand the pain and why even learning something as horribly obnoxious as Quark Express seemed like a godsend to me when I was younger. So the computer allows you to create these documents. It doesn't always have to go straight to print. So there are other ways of publishing, as you know. Some things aren't included here because they weren't an option when they wrote the curriculum. But you can get it printed. You can end up having it on DVDs and CDs for distribution. Some textbooks still come with those as a little disc in the back that also has enrichment computer information, although most of those are switched to online. Perfect segue to the internet's a great place to publish documents. Lots of things go there. And now mobile devices are also a way of getting your designs and your work published. But learning layout, learning typography, learning graphics, that works in the whole graphic communications industry and not just in my slice of it, which is printing. So hey, learn this stuff. Some of the exact specifications change from thing to thing, but the general concept and the logic of how you create layout for humans to look at, read, and understand, and how you also translate that so the computers involved in output can understand it, that is the skill that I'm hoping you guys are getting from me. So you need a couple different things. Early computers were built out of multiple components strung together by wires, which made it a little bit easier to determine what it was what. Now in the days of laptops and iMacs and that sort of thing, so many computers are all in one box that you don't see the difference as much, but there are still separate things. You still got your inputs, you've got your CPU, output devices, and storage and archiving. Some of these things are still in use, some of them have fallen by the wayside. Let's take a look at some of this stuff. Point and click. Like me, point and click, the GUI, the graphic user interface, that is all products of the 80s. This is from the time and space I come from, literally because my dad worked for Xerox and worked on developing print systems based off of this during the late 70s and early 80s, right when this was starting to become a thing. So I am literally a biological product of someone who worked on this type of system. Also, so are all my best friends growing up. Their parents also worked for Xerox, and they also helped develop the print world that we know today, as well as the computer world. So the Mac OS was the one that really made it catch on for everywhere, but Xerox first invented it with their STARS system on the Alto computer, although the Apple Lisa and then the Apple Macintosh systems quickly followed, and then eventually IBM woke up and Microsoft existed and said, wait a minute, maybe people don't want to use our system, maybe we should invent something that looks like the Macintosh and the Xerox system. Let me show you a thing real quick here. In the before time, in the long, long ago. This is a video showing you DOS, the disk operating system. This was the IBM type operating system around the same time of early Macintosh. My friends had this growing up, and I also learned to use this. So in DOS and in other early computers, this is actually the best of this type, by the way, the most user-friendly of all of them. You would literally type commands on your keyboard in code language to your computer. That's right. You wouldn't click on folders or run things through clicking on them or looking through folders and looking through images and graphics. Oh no, you had to memorize series of code and type them in. And every once in a while you get the very, very, very rightfully feared bad command or file name, which let you know that what you typed was gibberish and or the computer can't find its own parts. Neither one of those is great. I'll be brief now. I know you know what a GUI looks like. You're using one to watch my video, but here's a brief one showing you just how modern this looked in 1982. This is someone printing a file using the Xerox Star interface system. You drag and drop. Oh my gosh, you could do that in the very first mouse system. They also invented the mouse itself as a tool. Here's a print pop-up menu. Oh my gosh, pop-up menus, they still exist. You type in some input, you tell it to go, repaginate. Sounds really cool. Xerox never meant for their systems to be widely used by consumers. They meant to only sell them to themselves, actually. They use it as an internal device so that they could create better printers and press systems. They never tried to market it. They probably should have. Otherwise, you guys would all now be using Xerox phones instead of Apple phones. And now we're back to the point and click. This is what made desktop publishing possible. There is a very high bar of entry. If you were going to try and use the DOS system to type out code to create an image, you'd have to basically compose PostScript by hand, which I suppose somewhere out there's a chosen one who can do this. It's not me. I'm a WYSIWYG child of the GUI era. Sorry. You'll have to find yourself another chosen one. Here we go. Here's a picture of a Macintosh system. This is an earlier OS 10 as opposed to the current OS 10. Pick your favorite national park. Moving on. So just the desktop workstation, you've had your CPU, your display, and the keyboard. The display is the screen that you're looking at the pictures on. The CPU is the actual processing system doing the work of the computer. Keyboard and mouse, I don't think none need much definition. And then you also have peripherals and input devices like scanners, external hard drives, cameras, other methods of storage, and transporting of files from one machine to another. Flatbed scanners used to be a big thing. They're not so much anymore. Flatbed scanners were a transitional thing. They're kind of, sorry, my little 4-year-old girl is currently getting into dinosaurs, so forgive my dinosaur analogies now. The flatbed scanner is a bit of the Archaeopteryx of the computer world. It's a transition from reptile to bird. So before digital photography was huge, but digital design was already catching on, this was a way of taking physically photographed pictures that were done on film and developed and printed on paper using the traditional chemical photo development process and getting them into a digital form. They would scan the picture and then you'd have a file on the computer you could work with. It was a half step. It was a way of bridging photography into the digital world because it actually took a while for digital cameras to come down to the price that photographers and home users could afford them. They existed for a while. I mean, they were developed in the 70s by the military and by NASA for interplanetary exploration and also spying on the Soviets. But they weren't quite down from defense industry cost to print shop cost to photographer taking pictures of your wedding cost. It comes down a ways before it's finally available to the mass market. So this was a way of giving those types of sensors just to the print shops. And there was an entire career available as a scanner operator. You could work for a print shop and your whole job would be to scan photos people took. In fact, some of the best color management systems in the world, for those of you who have been in my color management cult, I mean class. Did I say cult? In my color management class, we talk about this. His name is eluding me right now, but the inventor, Don Hutch, there it was his name. I actually learned directly from him. Don Hutch, the inventor of the G7 color management system, invented his color management system to calibrate scanners. So because he was a scanner salesman and the print shops needed to see a scanner work in a demonstration and give some sort of meaningful output. So we figured out how to wrangle the Wild West of their non-managed color by developing what is turning out to be the best color management system in the world. Spoilers, manage the gray levels. If you can take care of the gray, the rest of the color take care of itself. Digital cameras quickly replaced digital scanners as the way to get pictures onto a computer. They eliminated the middleman. Now you take a photo on a camera and it's directly already saving it as a digital file of some sort. Less steps, better workflow. Most people like this. Also, it means your camera can take thousands, or depending on how big of a card you have stuck into it, thousands or tens of thousands of pictures on one camera, instead of the old days of having 24 or 36 individual sections of film that you manually wound through the camera, so you could only take some pictures at a time before you had to change or reload. We live in a good time, and again, we're spoiled. The CPU is the central processing unit. This is the main section of your computer. This is where the motherboard and the processor and the hard drive all exist. This is where your computer processes the billions of calculations of ones and zeros and binary math and translates them into meaningful things that we want them to do. We're gonna go one more slide because we're running out of time. We're gonna have to do a second video for this one. So the CPU uses binary data. Ones and zeros is what it likes. Each pair of binary data, each 1 and 0, is a single switch. It's an electric pulse that either happens or doesn't. 1 is on, 0 is off. You might notice when you look at electronics that the power switch has a 1 and a 0, not an off and an on. 1 is on, 0 is off. So your computer is, even when watching this video right now, your computer is doing millions and billions of computations a second of adding up, and just by switching little tiny, imaginary electric light switches on and off. And that's all it's doing. So the better your computer can do these is the higher the clock rate. It's all about how fast can it flip on and off these tiny switches and then translate them into meaningful work.